given a circle, that one. So the arc length, that one, is the distance along the curved edge of the circle. So here, this one. So any point there. Okay, and the arc length is denoted as S, and that is equal to the radius times the angle, or the central angle. Okay, so if this is the angle and this is the radius, so this is S. Alright, what else here? Central angle in degrees. Okay, if it's in radians and then you want to convert that to degrees, you just multiply by pi over 180 degrees. Okay, like say for example you're given like 3 pi. You convert this to degrees, you multiply this by pi, 180 over 180 degrees over pi, because pi, the measure of pi is 180 degrees, right? Okay, then you cancel pi, then you'll have 3 times 180 degrees. So that is the equivalent of 3 pi. And then area of the sector. Okay, area of the sector here. Okay, for geometry, the area of sector with central angle, if the central angle. Okay, so the area is just equal to 1/2 angle, the angle, right, r squared. Is it the same as in your book? Okay, theta, the angle, the central angle, 1/2 central angle times r squared. How come it's okay? Assuming that your central angle is in radians, then the area is 1/2. Okay, so it should be 1/2 theta r squared. So if it is in radians, then you can just convert it to degrees. You do the same thing. You multiply by 180 degrees over pi. Okay, so shall we start solving, what's this, the first problem here? Okay, I will delete this. Find the exact value of the arc length of the circle with the radius. Okay, we're given the radius 6 yards, and central angle is equal to pi over 8. So we find S. Since S is equal to the radius times the angle, so we just plug in the given values. Right, so that is 6 yards times pi over 8. Okay, so this would become 6 pi over 8, and then we can reduce 6 over 8 since both 6 and 8 are divisible by 2. So this would become 3 pi over 4, or 3/4 pi yards. Okay, got that? No questions in that? Then we have number 12, the next question. Find the exact area of the sector. So we're asked for the sector, area of the sector, with diameter equals 1.4 inches, and then central angle 5 pi over 4. So the area is 1/2 theta r squared, right? We're given the diameter, so diameter is twice the radius, so we have to divide this by 2. to find the radius. So radius is 1.4 over 2. What is 1.4 over 2? Okay, 0.7 inch. So that is the radius. We're given the central angle. Now we can find the area of the sector. We just plug in everything. So times 5 pi over 4 times 0.7 squared. So this is 5 pi over 8. What is 0.7 squared? Okay, 0.49. Then we simplify 0.49 times 5 is 2.45 pi over 8 divide 8. So this is 0.306 pi inch squared. How come it's different from your book? 0.49, 5 over 4, 5 over 8, right? 5 over 8 times 0.49. 0.49 times 5 divide 8. So that is 0.30625 pi square inch. So pi is 3.14. So this is 0.9696 square inch. Okay. The questions on arc length and area of the sector. Okay, so let's move on to linear and angular speed. So what's the difference between them? So when we say linear, linear is how fast a point on the circle moves along the arc. So that is the distance per unit time. Yeah, distance. This is the example we denote the linear speed as v. So that is distance over time. Let me check if it's the same. Yeah, the same there. And then this is for linear speed. Linear speed. How about the angular speed? So the angular speed measures how fast an angle changes or how quickly an object rotates around a circle. So it is denoted as omega. This is omega is equal to the angle or theta. Angle, central angle over time. So the angle here is the central angle. So the angular, Okay, so for the linear one, this is the speed or measures how fast a point on the circle moves along the arc. So if this is your circle, okay, so if you have one point here, so the speed from that point to another point along the arc, the point on a circle moves along the arc. So the distance from one point to another point, the speed of that distance. And for the angular, how fast an angle changes. Like say for example, okay, this is the radius, right? So let's say the angle starts here. Let's say this is our central angle. So if we move this one to here, yeah, see? The angle changes, right? Moves, yeah? So that is the angular speed. The linear speed is here on the arc. Okay? Relationship between linear and angular speed. Okay, you're given there. So that one is you're only shown how to derive that one. Let's start with the problem. Okay. A car travels at a constant speed around a circular track with circumference equal to 3 miles. Circumference equal to 3 miles. If the car records a time of 12 minutes, so 12 minutes for 7 laps, what is the linear speed of the car in miles per hour? So miles per hour. Okay, we're given here the circumference of the track, which is 3 miles, the laps, which is 7, and time in 12 minutes. So how are we going to find the linear speed? Again, linear speed is equal to, or we denote that as V. V is equal to S over T. Write the distance over time. Right. Okay. So we find the total distance traveled first. It says here 7 laps. So each lap is 3 miles, right? Lap. So each lap is 3 miles. Each lap is equal to 3 miles. So the total distance would be, because we're given 7 laps, so 7 times 3 miles. So that is 21 miles in total. That is the distance. Or we denote it as S. And then we're given 12 minutes. 12 minutes, but we are asked for distance per hour. So we need to convert the time from 12 minutes to hour. So this is 1 hour over 60 minutes. So what is 12 over 60? Okay, 0.2 hour. So now we already have the distance in miles and time in hour. So we can now find the speed, which is distance over time. So 21 miles per 0.2 hour. So what is that? 21 divided 0.5 is, no, 21 divided 0.2. 21 divided 0.2 is 105. 105 miles per hour. Yeah, is it the same? Okay, who solved this? 107 miles. Yeah, you got it correctly. Let's see. Okay, is it confusing for you? Your notes? No, the formulas on the top is just how to derive. So you only need to know the formula for linear and angular speed. So linear, that is distance over time. Angular is the central angle divided by time. The relationship here, they are just, to show you how we ended with those two formulas, the linear and angular speeds. We ended up with those. Yeah, that's why I ask you whether your notes is confusing for you. Yeah, because I can see that what. All right. Okay, so let's move on to number 14. A lighthouse in the middle of a channel rotates its light in circular motion with constant speed. If the beacon of light completes 3 rotations, okay, we're given 3 rotations. every 12 seconds. Find its angular speed. Angular speed is equal to the central angle over time. So it should be radians per minute. We're given here 3 rotations every 12 seconds. So the first thing we do is find the total angle. Okay, take note that one rotation is equal to 2 pi radians. Right? If this is your circle, one rotation is 360 degrees or 2 pi. So now we can find the total angle in radians covered in 12 seconds. So we have 3 rotations times 2 pi. So this is 6 pi radians. Okay, so that is the angle, the total angle covered in 12 seconds. So now we can find the speed. So angular speed is 6 pi radians over 12 seconds. So this is 0.5 pi radians per second. What's in your book? Or is it 30 pi? Huh? Yeah, per minute. Yeah, we need to convert seconds to minute. I'm sorry, I didn't convert that. Okay, let's just convert that. So we have 6 pi here, radians. We convert seconds to minutes. So this is 1 minute over 60 seconds. So this is 6 pi radians over 12 over 60. 12 divided 60, that is 0.2 minute. Then 6 divided by 0.2, so that is 30 pi radians per minute. Okay. Alright, you got this? No problems? Then we move on to the last problem. For a point traveling along a circle that is a radius of, we're given the radius 2 mm. Angular speed is 6 pi radians per second. Find the distance the point travels over an 11-second interval. So we find S, yeah, because we're not, we find S on 11-second interval. Okay, so what are we going to do first? What's the formula for S again? Distance? Radius. So we need to find the central angle. So angular speed is equal to the central angle over time. Right? So central angle is, okay, we plug in. We find the central angle. So central angle is equal to the angular speed times time. So that is 6 pi radians per second times the time. Time is 11 seconds. So this is 6 pi radians. What's this? The angle. And now we can get the distance. Find the distance. So distance is equal to the radius 2 millimeters times 6 pi radians. So this is 12 pi. Oh no, it should be 66, right? Because 66 times 11 is 66. So 66 pi radians. So this is 66 pi. So 66 times 2, that is 132. 132 pi mm. Then we convert that to, or we don't need to convert that, right? Because it's not indicated in the problem. So that is 132 times 3.14. So this is 414.5 millimeters. So that is the distance. Yes. And pi, I used 3.14 and I got 414.5. So maybe because I rounded off. But yeah, maybe if you just multiply 132 times the exact value of pi, then you will get 414.7.